Hello everyone, I'm Granata Van Ridho. Isochrones are theoretical models that depict the evolutionary tracks of stars on a Hertzsprung-Russell HR diagram, showing how their properties change over time. In cluster fitting, these isochrones are overlaid onto observational data such as color magnitude diagram aka CMD to find the best fit model that matches the cluster observed characteristics. By adjusting parameters like age, metallicity, and distance, astronomers can align the theoretical isochrone with the cluster distribution of stars on the CMD. This fitting process allows astronomers to estimate the age and other properties of the stellar population within the clusters, providing valuable insights into its formation and evolution. Alright, let's get to the problem and also the answer. Alright, which clusters is the oldest of the one that I chose and how old is it? The answer is NGC 752 by 1.413 gigayears. Which clusters is the youngest of the ones that I chose and how young is it? Alright, so the youngest cluster is 30 Doradus LMC by 0.063 gigayear. How do the age of this star cluster compare with the age of the Milky Way? Alright, for the A section, comment on when you think they formed in the lifetime of the Milky Way. So my answer is, according to the space.com, the age of the Milky Way galaxy is 13.61 gigayear. The average age of star cluster that I have previously observed is 0.348375 gigayear. So the impact of the age of the star cluster on the age of Milky Way galaxy is only 2.55%. In other words, the star cluster is 13,261.625 million years younger than the Milky Way galaxy. Alright, in the B section, do you think you can draw a strong conclusion with the number of clusters that I have fitted? Alright, the answer is the observation samples of the number of clusters that have been fitted are still to view. The result will be inaccurate if we are forced to draw general conclusion regarding astronomical observation. Most samples are needed, obviously, to get results with a low margin of error. Which cluster is the most distant and which is the closest? Alright, for the A section, given that all of these clusters reside within our galaxy, comment on what this cluster tells us about how big the Milky Way galaxy could be. So the answer is, it is known that the closest star cluster is CYG-OB2, which is 24.210 parsecs away. Meanwhile, the most distant cluster is 30 Doradus LMC, 2618.2 parsecs away. The diameter of Milky Way galaxy, according to NASA.gov, is 105,700 light years, or around 32423.61 parsec, 0.31 parsec. It can be concluded that if all the clusters that we have observed resided within our galaxy, then the distance of the farthest star cluster would not be comparable to the diameter of the Milky Way galaxy. And then for the last question, what did I learn during this experiment? Alright, during the experiment exploring the color magnitude diagram aka CMD, and then zero age man sequence aka ZAMS and isochrone using the virtual educational observation Vireo, I engage with the vital tools for the understanding stellar evolution populations. Through the CMD within Vireo, I learned to interpret the relationship between a star colors, or indicative of temperature, and its magnitude or brightness. This enabled me to identify the ZAMS, representing the main sequence of stars at the beginning of their evolution. By overlaying isochrones on the CMD, I also explored how stellar population evolved over time, comparing theoretical models with observed data to estimate the ages of star clusters and stellar population. These experiments provided me with a focused understanding of how these tools within Vireo facilitate the study of stellar evolution and population characteristics. Alright guys, Maybe that's all from me. Thank you very much for your attention and cheerio. Bye bye.